This is lesson 9 on decimal expansions of fractions part 1 for 8th grade, module 7. So we're going to go ahead and kind of continue what we've been working on the past couple lessons. We're going to look at these two numbers, 5 6 and 7 ninths, and we're going to find their decimal expansions. So let's go ahead and start by writing. We have 5 6 and then we have 7 ninths. So let's see if we can find out what their decimal expansions are. So we're going to grab our calculator. Go ahead and clear that out. We have 5 divided by 6, which gives me 0.8 and 3 repeating. So I'm going to say 0.8 and 3 repeating. Now let's try 7 ninths. I'm going to say 7 divided by 9, and I get 0.7 only. Now that little 8 at the end is only just because it's the calculator. So this is 0.7 repeating. And those are my two answers for that problem. Let's look at the next one. I have to add the two fractions. So I'm going to say 5 over 6 plus 7 ninths. Well, you know you need a common denominator. My common denominator here is going to be 18, which means I have to multiply this whole fraction by 3 and this whole fraction by 2, giving me 15 over 18 plus 14 over 18. And so now that I have common denominators, I can go ahead and add these up, and I get 29 over 18. So we'll take my calculator here, and we're going to do 29 divided by 18, and I get 1.6, and then 1's repeating. So we're going to say equals 1.61, and the 1 is repeating. Now we're going to look at these fractions and multiply them. So we're going to say 5 6 times 7 ninths. Check your diagonals. Nothing can be canceled. So we're going to say equals 35 over 54, and that's just multiplying straight across. Take my calculator. We're going to say 35 divided by 54, and I get 0.648148148. So we have a pattern, but it definitely broke for a little while there. So our final answer here is going to be 0.648 and then 148. All three of those are repeating, so the bar goes over all three. Now this one here says, if you were given the decimal expansions of those two fractions, knowing the fractions produced them, do you think you could easily add the two decimals together to find their sum? Could you easily multiply these two fractions together to find their product? So I want you to kind of think about that. We had those answers at the very top of 0.88 and 3 repeating, and the other one was 0.7 repeating. Is there a way you could take these two long repeated never-ending decimals and actually add them? And then could you take those same decimals and multiply them? I'm going to say no. And the reason we say no is because the decimals are infinitely long because they go on forever. It is not clear where to even start. So you can't possibly start adding these numbers up because you have to start with the first column on your right. And if that first column on the right never stops, it keeps going on and on and on, you'll never get to the first column on the right. They're always going to be repeating. So that's why I said it's not even clear on where to even start. All right, what about multiplying them? I'm also going to say no to that. I'm going to say no. To multiply, could you imagine multiplying these decimals that never seem to stop? So to multiply infinite decimals would be even, I don't know, let's just even say even harder. because there's possible carrying over and all kinds of stuff going on. Where would you put the decimal? How many decimal places would it go? So in this sense, yeah, no, you could not be given those repeated decimals and possibly come up with 5/6 over 7/9. All right, let's keep going. So two irrational numbers, x and y, have infinite decimal expansions that begin with these two expansions here that you have. They're using this first expansion here for x. So this is for x, and this one over here is for y. So it wants to know, explain why 0.670 is an approximate for x with an error that's less than 1,000th. Explain why 0.849 is an approximation for y with an error of less than 1,000th. All right, so we're going to kind of talk about errors here. What we're basically trying to do is narrow the error ability down. Nobody really likes to have an error. We try to keep things where everything works out. And by doing that, narrowing the gap makes it easier to kind of control. So we're going to talk about the difference. What is the difference between what they gave us here and what they gave us up above? So we're going to say the difference between. All right, so we had 0.760 coming from right here. All right, and we're going to compare that with this longer version up here. 0.6703527. Now I wanted to know what the error is of 1,000th. Well, let's see what number is in the thousandth spot. Tens, hundreds, thousands. So I'm going to cut it off right there. And that's how I got 0.670. So the error difference in this one is 0.0003527. Notice that my first three numbers here, 670, were separated, leaving those spots empty, so we put zeros in their places because these numbers still need to wind up in the correct placement that they were already in. They can't just move up closer to the decimal because now we've changed their value. Let's try the next one. We have 849, and that's coming from the y here, which is 0.84991,341. And again, this is for the thousandths place, so tens, hundreds, thousands. That's where I'm going to cut it off, which is how they got that number there. And so its error is 0.00091,341. All right, so if you look at both of these here, we're going to say that both are 0.001 of a difference. There's not much of a difference between these. So that means that the error gap is very, very close. Let's try this next one here. All right, so we're going to take those numbers that they gave us. I'm going to rewrite them here because it's up on the other screen. For x, they wanted us to use 0.670, and for y, they wanted us to use 8.49. All right, so now we're going to fill them in. We're going to add the two numbers, then we're going to multiply the two numbers, and then we're going to square and multiply those numbers. So let's just start by doing the x plus y. That's going to be 0.670 plus 0.849. And if you do that on your calculator, you should get 1.519. All right, let's multiply them. X times y. And that gives me 0.670 times 0.849. And check that on your calculator. You should get 0.56883. And what if we had x squared plus 7 times y to the second power? This is going to be 0.670 and I'm going to square that, plus 7 times 0.849, and I'm going to square that. Now for this one, I'll pull up the calculator just so you can see what I'm doing here. All right, so we're going to do 0.670, and I'm going to square it. And I get, I'm going to put it over here, 0.4489 is the answer to that part right there. Plus, now I'm going to do my squaring first and then times that answer by 7. So I'm going to say 0.849 squared gives me that, and I'm going to go ahead and just hit times 7. So this answer here is 5.04567. All right, now I need to add those two numbers together. So I'm going to just leave it on my calculator and hit plus point, and I'm going to add it to this number here, 0.4489. And therefore, my final ending answer is 5.494507. And that's my final answer there. All right, let's look at C. C says, repeat part B, but use the approximation of X and Y that have errors less than 1 over 10 to the 5th power. Well, first, let's go ahead and explain what 1 over 10 to the 5th power is. That's going to be 5 numbers after decimal. So 1, 2, 3, 4, and 5 would be where the 1 goes. Okay, so that's 1 10 to the 5th power. So what place value is that? That's tens, hundreds, thousands, 10,000s, 100,000s. So that is a very small margin. So if you remember from my number up above, we had 0.6703527. Which place value matches that? So you could just count in 5 places. 1, 2, 3, 4, 5, and that's your cutoff. So these are the numbers I'm going to use. So 0.67035. Now let's do the Y. The Y is 0.84991341. Let's count in 5 places. 1, 2, 3, 4, 5. There's my cutoff there. So I'm going to use 0.84991. All right, so now what do they want us to do with these numbers? They want us to go ahead and add them and then find out what their error is. Oh, actually, no. They just want us to find out the error is. I apologize. So just find out what the error is. So this one here, the error is what's left. So these all become zeros, and then you put what's left. So we're going to put 0.1234, 1, 2, 3, 4, 5 zeros, and then 2, 6, 7. This one here, its error is 1, 2, 3, 4, 5, and 3, 4, 1. Which you can see both of these is less than 1/100th or 1/100,000th of a error. That's a very, very small margin. All right, let's go on to the next one. So on to the back. So onto the back, you're going to do the exact same thing we just did on the front, just with 2 different sets of numbers here. So I'm going to have you guys do A through D on your own, which will then end this video segment. All right.